Alright dear children, now let's do next question, the last numerical problem, okay, from this chapter photoelectric effect. Now this is a problem based on graph, one of the important graph expressed by Hertz and Lennart to explain the phenomenon called photoelectric effect. Okay, now this problem number 6, this is actually problem number 6, sorry, this is problem number 6. Last YouTube video we have done problem number 5. Now problem number 6 says that in an experiment of photoelectric effect, okay, in an experiment of photoelectric effect, the graph of maximum kinetic energy, that is Ek of the emitted photoelectrons versus the frequency, that is nu of the incident light, is a straight line. What type of graph? Is a straight line shown in figure. Is a straight line graph shown in what? Figure. Now you know kinetic energy depends upon the frequency. When the frequency of incident light increases, kinetic energy also increases. That's why the nature of graph will be a straight line but not passing from the origin. And that graph is shown out here. This is the graph. So this is y-axis, this is x-axis, children. Okay. So your x-axis I have taken as frequency, and this frequency is measured in the hertz. Your y-axis is starting as Ek, which is measured in electron volt. So electron volt is the kinetic energy, maximum kinetic energy. So from this graph only we have to calculate two different parts. Okay, three different parts. Sorry. So the first part that we need to calculate in this question is threshold frequency. So we have to find the threshold frequency. Then after second part, we need to calculate work function, which is marked by symbol W of cathode metal, and this work function we need to calculate in electron volt. And lastly, even we need to calculate stopping potential for electrons emitted by light of frequency. Frequency of light is given, that is 30 into 10 to the power 14. This is 10 to the power 14, not 4. It's 10 to the power 14 hertz. Okay. So in order to solve this problem, let's go through this graph. Okay. So if you look at this graph, this is a straight line graph where AB is a straight line that passing from this, not from the origin, but starting from this point. But this line which you can see is also a dotted line. That is a line which is intersecting on the negative energy axis at -4. Now this electron volt starting from 0, 2, 4, 6, 8 volt. This is the frequency which is given 0, 10, 20, 30. But this frequency is in the power of 10 to the power 14 hertz. Okay, 10 to the power 14 hertz. So from this graph, the first thing that we need to calculate is, okay, so we do the solution of first part of the question. We need to calculate threshold frequency. And children, you know what is threshold frequency? Is the minimum frequency required to eject the electrons from the metal plate. And that is threshold frequency. And from the graph, this point is the minimum frequency where the line has started. I mean this line starting, this straight line starting means the photoelectron start ejecting. But this is the minimum frequency of the incident photon where the photoelectron just eject. And this point A, which is marked by the frequency which is 10 but with the power 10 to the power 14, is the threshold frequency. So as per the graph, this is threshold frequency, because this graph is similar to the graph which was plotted by Lennart and Hertz. So you have done this part, children, and this is important graph also. So this point measures threshold frequency. So from the graph, children, the threshold frequency, which is marked by letter nu naught, is 10 into 10 to the power 14 hertz. So let me write this way only, 10 into 10 to the power 14 hertz. That is the threshold frequency of this light. Okay. So first part we calculated, the threshold frequency we calculated. Now the second part that we need to calculate from the graph also is work function. What function? Work function. Now you know work function is measured on which axis? Y-axis, the energy axis. And children, you know what is work function? It is the minimum energy required to eject the photoelectrons from the metal plate. So with respect to this frequency, if you draw a dotted line, which has already drawn, is meeting at -4 energy axis. So this is work function. So this is how much energy total? -4 electron volt. But you know work function is a negative function, but we write as 4 electron volt only. Work function, which is W equals to 4 electron volt. So from this graph, this is a work function. So work function of this metal is 4 electron volt, which is the minimum energy that is required to eject the photoelectron from the metal plate. Okay, this is the second part of the question. Now the third part of the question is to calculate the stopping potential. What do you need to calculate? Stopping potential for electrons emitted by light of frequency. How much? Mu equals to how much? 30 into 10 to the power 14 Hertz. But children, to calculate stopping potential, most important thing that you need to know is maximum kinetic energy, because stopping potential is always measured in terms of maximum kinetic energy of photoelectrons. But stopping potential we need to calculate in this frequency, that is 30 into 10 to the power 14 Hertz. But this frequency can be seen from the graph also. So at this frequency, first we calculate what? Maximum kinetic energy. See, if you look at this straight line graph, this is frequency 30 into 10 to the power 14 Hertz. At this frequency, if you see there is a dotted line which has already drawn. At this frequency, 30 into 10 to the power 14 Hertz frequency, you can see the line which is meeting at this point. So this is 8 electron volt, and that is the maximum kinetic energy of photoelectrons. This is the maximum kinetic of photoelectrons, which is 8 volt in 30 into 10 to the power 14 Hertz frequency. So I write down EK at 10 into 10 to the power 14 Hertz is equals to how much? 8. Yes, this is 8 electron volt. So your maximum kinetic energy of photoelectrons at 30 into 10 to the power 14 Hertz is 8 into 8 electron volt. So from here we can calculate the stopping potential. Now since you know EK equals to what? EB naught. So maximum kinetic energy of photoelectrons equals to EB naught. So B naught means EK by what? E. So EK means how much? 8 electron volt by E. Okay, so I do this side. But electron volt I convert into what? Joule. So it is multiplied by 1.6 into minus 19 joule by the charge is how much? The charge is how much? 1.6. Electron charge is 1.6 into 10 to the minus 19 coulomb. So charge of electron is 1.6 into minus 19 coulomb, and I converted electron volt, 8 electron volt into joule. So this and this cancel out, 1.6 and 1.6 cancel out. So 8. Now joule per coulomb means volt. So children, look at this. What is the stopping potential? 8 volt. So this is the negative potential that you need to apply so that the photoelectric current becomes 0. So what is the stopping potential? It is 8 volt. Okay. So this is the solution of problem number what? 6. So we have done 6 numerical problem, important numerical problem. But children, there are so many other numerical problems that you need to try by yourself. Okay, from the textbook. Okay, in case if there is any problem you face, not able to solve the problem, please feel free to ask. Okay, so we have completed chapter photoelectric effect. Now we move to the next chapter, the last chapter as per reduced syllabus, under unit number 7, matter wave.